Hi, my name is Tom Gonzalez with Brightpoint Consulting, and today I wanted to introduce you to some open source data visualization technologies coming from the team at Uber. They've been working on these frameworks that I'm about to show you for I think about the past 3 years or so, and it's a pretty complete and robust set of data visualization frameworks. And what's different about this technology than some of the technology that's preceded it is this all leverages vis.gl. And vis.gl is an in-browser based technology that works off your graphic processing unit. And what does that mean for the average user? It means high fidelity game quality graphics within the browser. Typical data visualization frameworks in use today leverage SVG, the canvas component with some underlying raster rendering, but there's a real limitation in terms of how many data points you can show simultaneously. Typically capped in the thousands, maybe 10,000. With vis.gl technology, you can show millions of data points simultaneously. So I'm going to do a quick run through on the overall frameworks and how some of these pieces fit together, and then maybe in some subsequent videos I'll do a deeper dive into some of these component pieces. So vis.gl is the URL, and I'll leave these in the description below. One of the first frameworks I wanted to talk about, or actually the second, is called geo-spatial, which is a geospatial mapping framework that they've built. Sitting underneath that is Luma.gl, which is their JavaScript framework that allows you to program vis.gl directly, but much easier. And then on top of that is Kepler.gl, which is a user interface that will allow you to import data and visualize data with no programming. So jumping right into it, I want to show you Luma.gl. Luma.gl is Uber's JavaScript framework that allows you to program vis.gl graphics. Why is this important? Well, vis.gl, as I mentioned before, is a real high-performance graphics, in-browser graphics that allows you to render millions of data points simultaneously. In this case, we're looking at about, I think, 65,000 three-dimensional cubes. And you notice as I put my mouse over it, you can see hit detection working, where it actually highlights these in real time. I think this is running at about 25, 30 frames per second. If I didn't have the screen record, it would be higher. This is just running off a laptop. But pretty impressive browser-based performance. And why Luma.gl? Well, vis.gl programming natively is very low level. It's pretty time-consuming to work with. It doesn't really allow for rapid prototyping or development. But Luma.gl really abstracts out some of the underlying technology and makes it much easier to quickly program and quickly prototype and build this into your product offerings. So they have many more examples, and I'll dive into those in a subsequent video. Next up, I want to show you geo-spatial. And this really gives some meaning to what I just showed you. Luma.gl, while pretty and really high performance, doesn't really relate in the business context or that of a product that needs to do data visualization work. So geo-spatial, the concept here is you can work in different layers with data and objects. It is bridged into Mapbox, so you can get street information, map information, just like Google Maps, but in real-time 3D space. Allows for really high performance here. We're looking at different buildings that are color-coded based off of property values within Vancouver, British Columbia. I'm zooming in and out. I can skew and rotate these maps. In this case, they've disabled all the street names, but I'm drilling down into like high levels of detail here. Another example that I'd like to show you is their hexagon layer, which is really neat. So in this case, we're looking at traffic safety in the United Kingdom. I'm going to make an assumption that this is London based off of these hexagons, their height and their color coding showing these different accidents. You can adjust different things like the radius, upper percentile, lower percentile. This is just some cool stuff you can do on the fly. Really neat. They have many different layers. Let me show you their point cloud layer, because this isn't related to a map, but this is I believe like a LiDAR indoor 3D scan that's showing, I believe this is Frank Lloyd Wright's Falling Water. It looks very similar to that. But you can see here, really cool, just tons of data points. So What's neat about this is not hard to program. Within a couple hours, I was up and running and visualizing data. And so when you think about your product offering and your ability to visualize data, take a look at these frameworks. It might really accelerate your ability to incorporate some pretty impressive and engaging visualization into your work. The final piece I wanted to show you is called Kepler GL, and Kepler builds on top of vis.gl. So we've got Luma at the foundation, vis.gl in the middle, and what Kepler GL is a user interface that allows you to import your own data. In this case, I'm going to grab a little bit of the sample data here. It makes it a little easier to demonstrate this. This is some taxi trip information for New York City. It's loading up as we speak. And what we can see here is taxi trip info as a scatter plot. Let me just close down a couple of these other browser windows. They're sucking up some of the GPU energy. I'm zooming in. Kepler comes with a playhead or scrub head that allows me to adjust how much time is being shown at once. It allows you to animate this. So as this is animating over time, we see this scatter plot is changing. You can see different scatters coming in and out. I'm going to pause this and then show you another really neat feature. Like some of D3, for instance, is a data visualization framework, makes it very easy to bind data to visual properties. Kepler GL allows for the same thing. So here I'm going to adjust this drop-off point. Right now the color is a blue color, but I want to bind it to a piece of data. So I'm going to choose, let's see, trip distance. And I can choose different color spectrums that I want to color that data with. So we're looking at the spectrum based off trip distance. And now, instead of a static color, we have these different colors that are being shown. So really neat stuff. And once again, where I think this is really applicable is this is just a relatively simple user interface they put on top of vis.gl. It's open source. So if your company has any geospatial visualization products, or I should say does any work in the geospace or mobility space, this would allow you to really easily build a custom user interface for your users using this data within Maps. So anyway, that's the run through. Please look at the links in the description below, and I'll be reviewing each of these more in depth in some subsequent videos. Thanks so much, and thanks for listening. Bye-bye.